Okay, moving on to more arithmetic with radicals. We're going to talk about multiplying and dividing radical expressions now. The rule that we've been using, for example, on the last video when we had to simplify the square root of 12, we said 12 is 2 squared times 3 to the first, and so we quit writing this step in a couple of sections ago, but we said, well, it's the product of 2 squared under the square root and the square root of 3, so 2 comes out and 3 stays put, and our answer is the product of 2 and the square root of 3. Overall, the rule that we used said, assuming this radical here is completely well-defined and real number values and that sort of thing, that we can take the nth root of a times the nth root of b. So while we've been moving in this direction, up above, that's what we just did, the rule applies also in the other direction as well. Okay. Meaning that when we go to multiply and divide radical expressions, it works the way we would hope that it would work. Meaning if I want to multiply the square root of 2 times the square root of 3, I can do that by taking 2 times 3 and calling that the square root of 6. If I want, to remember how I built my boxes on this slide. If I want to multiply the cube root of 6 times the cube root of 3, I can take 6 times 3 and get the cube root of 18. Or the fourth root of 5 times the fourth root of 5 is the fourth root of 25. Or the square root of 6 times the square root of 2 is the square root of 12. And the top 3 examples, once I had square root of 6 or cube root of 18 or fourth root of 25, we were done. If you see the little blue factors written under there, I didn't have enough of anything to bring anything out from under. But multiplying square root of 2 times square root of 6, once I get all those factors together, I have enough 2's that I can keep going, and I can get that 2 out from under, and the 3 is still stuck underneath. So once I put my numbers together using multiplication, I need to do a quick check and make sure that I'm simplified completely in my radical before I'm done. Okay, I would like to do more of those. So if I have the square root of 6 times the square root of 15, 6 times 15 is 90. Now, however we get things broken down, it's always simplest to look at the numbers when they're smaller. But again, if you started with the 90 over here in the corner and went to 9 and 10 and kept going to 3 and 3 and 2 and 5, you can get there using either path. But 90 has in it 2 factors of 3, a factor of 2, and a factor of 5. Which means we have enough 3's to come out, and the 2 and 5 go back together. And so we'll get all the way to 3 times the square root of 10. If I have the cube root of 12 times the cube root of 10, I can start by multiplying 12 times 10 to get 120. I can break down my 120, however my favorite version of that is. I can go back here and I'm going to say cheat, but that's really not cheating, it's working smarter, not harder. And saying, well, if I put all those pieces together, it looks like I have 3 2's all together. 2 from one and 1 from the other. And I have a 3 and I have a 5. So my 2 could come out, and 3 times 5 is 15 left underneath. And finding the product of 2 radicals, I can just multiply the numbers or expressions underneath, and then in the end I need to make sure it's reduced completely. So I don't stop at square root of 90 and I don't stop at cube root of 120. I have to make sure that I keep going to simplify things. That's the wrong direction. Now if we look at down at the bottom where my gray boxes still are, if I want to take the square root of 7 times itself, I get the square root of 49, or the square root of 7 squared, and that's equal to 7. If I want to take the square root of 11 times itself, that's the square root of 121, or the square root of 11 squared. And the square root of 7 squared was 7. The square root of 11 squared was 11. And again, we talked about this when we were first simplifying radicals, that I'm looking for the exponent here. I'm pointing, but not drawing. The exponent here needs to match the root that we're working with. And when it does, then that factor is set free. So if I want the square root of 2036 times itself, then in the end, I'm going to get 2036. I'm going to sneak a peek right there. Okay. Now, anytime I take a square root times itself, I'm going to get that number, or that factor. When I took square root of 7 times itself, the square root of 11 times itself, the square root of 2036 times itself, I got 7, 11, and 2036. Notice, however, that's not exactly the same thing that happens if I'm looking at cube roots, or another root. If I take the cube root of 2 times the cube root of 2, I get the cube root of 4, which doesn't simplify anymore. If I want to take the fifth root of 7 times the fifth root of 7, I get the fifth root of 49. Hopefully this writes over the top of my gray box there. The rule from the other page still applies. We just multiply the numbers or expressions underneath. We keep the fifth root there, or the cube root there, or the square root there. But when I multiply a square root times itself, it makes things go away. Now, I've lost my slide. Somebody somewhere along the way said, made a rule in algebra class and said it's not okay for there to be a square root or a cube root or a radical of any sort, an irrational number in general, on the bottom of a fraction. Okay, so our job, if we end up with an answer, or if we're given a problem like this out of the book where we have a square root of 2 on the bottom, or a cube root of 7, or the fifth root of 9, okay, then we have to write it in a different form. That different form has to have the same value as what we started with, but we're going to make it look different. The idea that we're going to use here is the same idea that we use on a very regular basis. If I want to rewrite the fraction 3/5, and I say I don't want 3/5, I need something over 20. And we say, well, I know how to get from 3/5 to something over 20. And we do a lot of this internally in our minds. We don't write this step on our page every time. But so we can see what somebody's thinking here. We say, well, I'm going to multiply the top and bottom times 4. And we know that we're allowed to do that because 4 over 4 is equal to what? Okay, and you're all yelling 1 at your desk. Okay, so if I multiply a number times 1, I have not changed its value. But when I multiply by this particular form of 1, I can change the way it looks. It meaning the 3/5. Now, if I type 3/5 into my calculator, it's going to tell me that's worth 0.6. If I take 12 over 20 in my calculator, it's going to tell me that's 0.6. Okay, multiplying by 1 does not change the value of the number I'm working with. But multiplying by a funny-looking form of 1, I can make it look different and adjust it to whatever I need it to be. Maybe instead of being over 20, maybe I need it to be over 15. Let's say, well, that's easy enough. I can take the number times 1 in the form 3 over 3 to get 9 over 15. It's the same thing we're going to do up here with the radical. I have to pick a form of 1 so that when I multiply that fraction times 1, it's still worth the same amount. But I need to make it look different, and I need that radical not to be over the top of the 2 anymore. On a couple of pages before, I'm going to click back a little bit, sorry. Okay, down here at the bottom left, we discovered that if you take a square root times itself, it disappears, and it goes away. Okay, so back to where I was. If I want to get rid of the square root, that's hanging over that 2, I can take the square root of 2 times itself to make that radical go away. But in order for me to keep the equivalent value there and not change what this guy is worth, I also have to multiply the square root of 2 on top. Anything you multiply times the bottom, you have to multiply it times the top, or vice versa. So on the top, I have 5 times the square root of 2. On the bottom, I have plain old regular 2. Okay, the only thing that I would have to keep in mind from there is I want to check and see if we're in lowest terms. Okay, with these pieces here. You don't ever cancel something under a radical with something that's not. Okay, so since 5 over 2 is in lowest terms, then my fraction itself is in lowest terms, and I would circle 5 square root of 2 over 2, because that's my fraction in its acceptable form. Okay, we'll do more examples of these in the next video. I'm getting kind of long.